let's dive straight into CoreAIoT technology. We're looking at their positioning tech, specifically focusing on 2023. So, who are we talking about? CoreAIoT is a startup, but they've carved out a niche in high-precision positioning. Think of them as the specialists in finding things accurately, especially indoors where GPS often throws its hands up. They're not just playing around. They were the first in China to mass-produce BLE AOA locators back in September 2019. That's pretty quick thinking. Over the last 3 years, they've really poured resources into R&D for BLE AOA, developing their own array antennas and algorithms that are now considered top-tier. Their main game is split into two lines, the established BLE AOA line, which you'll see everywhere from smart factories to hospitals, and a newer, exciting one combining UWB and AOA. This UWB plus AOA combo is designed to tackle the need for knowing both distance and direction for tons of IoT devices. It's like giving your devices a sense of space and orientation. Let's zoom in on their product journey. Remember that 2019 BLE 5.1 standard release? That was the spark. CoreAIoT didn't just watch. They jumped in, leading the charge in China. They went from zero to a fully functional system in just 5 months. That's impressive speed. By 2022, building on that BLE AOA expertise, they launched their UWB plus AOA modules. Why this shift? Because the world needs more than just knowing where something is. It often needs to know how far away it is and which way it's facing. Think anti-loss tags, tracking luggage, or even managing vehicles within a facility. This timeline shows the progression from early research to mass production and expanding into new product lines. It's a clear story of innovation and market response. Now, who's behind this tech? About 20 colleagues strong. They say they're well-rounded and highly efficient. Let's break down the team structure. You've got the hardware gurus, RF antenna engineers, and test folks making sure the physical bits work. Then the embedded and algorithm engineers, the brains figuring out the software side. Full-stack developers bridging the gap, front-end product engineers shaping the user experience, and software testers ensuring quality. Plus, technical support, marketing, R&D assistants, production engineers, and supervisors. It's a pretty comprehensive setup, covering everything from design to deployment and customer interaction. Those pictures show collaboration, focused work, and learning, which fits the description of an efficient team. Okay, let's get specific about the tech. First up, BLE AOA, branded as Core Location. This is their bread and butter, the high-precision indoor positioning solution. It's all about using Bluetooth signals cleverly to figure out where things are inside buildings. Then there's the newer kid on the block, UWB plus AOA, called Core Sensing. This one adds ultra-wideband technology to the mix. While BLE AOA excels at location, UWB plus AOA brings in the ability to measure distance and direction very accurately. It's like upgrading from knowing someone's address to knowing exactly how far away they are and which direction they're facing. Both are crucial for different applications. How does BLE AOA actually work? Imagine you're trying to pinpoint a radio signal. A simple antenna can tell you the signal is coming, but not from which direction. Now, picture an array of antennas, like a small dish. By analyzing the slight differences in signal arrival time or phase across the array elements, you can calculate the angle of arrival. That's the core idea. BLE AOA uses this principle with Bluetooth low-energy signals. The diagram shows this concept, measuring azimuth, basically the horizontal direction, and potentially elevation. The second image illustrates the practical application, showing how this tech can provide high-precision coverage in an indoor environment, distinguishing between areas with different levels of accuracy. It's all about leveraging existing Bluetooth infrastructure in a smarter way. Here's a key difference in how BLE AOA can achieve positioning compared to older methods. Traditionally, to get a 2D position, you'd need multiple sensors, typically 3 or 4, triangulating based on signal strength or time of flight. Think of it like needing several lighthouses to figure out your ship's exact spot on the map. But BLE AOA, thanks to its angle-finding capability, can achieve 2D positioning using just a single locator. It measures the angle of arrival, combined with the known position of the locator, to determine the target's location. This is a significant advantage, reducing deployment costs and complexity. The diagrams illustrate this. One shows the single locator determining angles, while the other hints at the traditional multi-sensor approach. Fewer sensors mean less hardware, easier installation, and lower maintenance. And here's the claim. They were the first in China to deliver a complete BLE AOA system, both hardware and software. This isn't just about selling chips, it's about providing the whole package. The diagram breaks down the components, the AOA locators, the tags that transmit signals, the core location engine software doing the heavy lifting of calculations, configuration tools, API services for integration, and the final RTLS application. Notice the workflow. Configure the devices. The base station receives signals, the engine processes them, and the data flows to the server. Importantly, it supports a reverse channel, allowing devices like smartwatches or phones to communicate back to the base stations. This closed-loop system is crucial for real-time, high-precision tracking. So, how do you actually set up this system? The network topology gives us a bird's-eye view. You have the central server running the core software, connected to PoE switches. These switches power and connect multiple positioning base stations. Each base station then communicates wirelessly with the BLE tags or locators scattered throughout the area. It's a hierarchical structure. The table below details the components, display devices for monitoring, the various types of tags, network gear like switches and cables, and the crucial software, including the positioning engine and business management systems. This setup allows for scalable deployment across large areas, from warehouses to hospitals, enabling sophisticated management of people and assets. Let's look at a real-world example, a fully connected intelligent manufacturing factory using 5G and AOA fusion. This isn't just BLE AOA anymore, it's a step up. They mention it's the first global application of this fusion tech in smart factories. What does this mean? It's about integrating the high-speed, low-latency communication of 5G with the precise positioning of AOA. In this case, it's used for intelligent warehousing. Forklifts are tracked with sub-meter accuracy, and this information is directly linked to the warehouse management system. The results are impressive. Shipment loading efficiency increased by 50%, and warehousing costs were reduced. That's a tangible ROI. The factory manager's quote highlights the impact. The images show the automated warehouse layout, forklift operations, and even a GTS award, suggesting industry recognition. Now, let's switch gears to a more personal application: keeping kids safe in amusement parks. This uses the BLE AOA technology for precise, real-time tracking of children. Parents get alerts if a child wanders off, allowing them to relax and enjoy the park without constant worry. The quote from parents captures the frustration of searching for kids in crowded places. This system aims to solve that problem. The images show a typical Melon Club entrance and the vibrant, engaging environment inside. Imagine parents being able to track their kids' location on a map via their phone, receiving instant notifications if they enter restricted zones or get too far from a designated area. It's about peace of mind for parents and a safer, more enjoyable experience for families. Another interesting application is indoor navigation, specifically for the National Library. This leverages BLE AOA plus mobile phone positioning. Think about navigating a massive library, like the National Library of China. It's easy to get lost. This system provides turn-by-turn directions right on your phone. The left image shows the navigation interface, guiding you forward, turning right, etc. The right images show the grandeur of the National Library itself. By deploying BLE AOA locators throughout the building, visitors can use their smartphones to find specific books, exhibitions, or exits easily. It transforms a potentially confusing space into a navigable one, enhancing the visitor experience significantly. This slide shows a map of China, highlighting the geographical reach of CoreAIoT's deployments. It visually reinforces the point that their solutions aren't limited to one region but are being implemented across the country. The presence of contact information and website details suggests this is part of their marketing material, showcasing their nationwide footprint and inviting potential clients from different regions to connect. Who are the big names trusting CoreAIoT's tech? This slide lists some impressive customers and partners. We see Huawei, a global tech giant, and map app developers like Tencent Maps. Then there's a diverse group including hospitals like Huangling First People's Hospital, Tongji Hospital, and Xiantao Central Hospital, cultural institutions like the Yiheng.Yue Museum and the National Library, industrial giants like AVIC and Baosteel, pharmaceutical company Roche, public transport like Shenzhen Metro, and even sports brands like Nike. This broad range of clients across healthcare, culture, industry, and consumer sectors speaks volumes about the versatility and reliability of their positioning solutions. Let's look at some specific case studies. First, smart supervision in a Guangdong detention center. The goal was fine-grained personnel management and safety. They deployed the system in 3,000 square meters. The results? Precise location tracking, alerts for crossing zones, electronic fences for restricted areas, automated roll calls, and anomaly detection. It's about ensuring security and order. Second, intelligent data center in Shanghai. Again, personnel management and safety, but in a massive 10,000 square meter data center. They achieved sub-meter accuracy, zone crossing alerts, electronic fences, automated attendance, and intelligent inspection routes. Keeping track of staff and equipment in a complex environment is critical. Third, smart hospital in Shanghai VIP wards. Here, the focus was on patient location management and tracking critical medical equipment. Deployed in about 3,000 square meters, it provided real-time patient location and equipment tracking with sub-meter accuracy. This helps improve patient care and manage valuable resources efficiently. Continuing with the cases, smart safety production in a Xiamen shipyard. The need was for worker safety and fine-grained management. Deployed in 5,000 square meters. Result, real-time worker location with sub-meter accuracy, 0.3 meters in key areas, ensuring safety near hazards and electronic fence warnings. Crucial for preventing accidents in hazardous environments. Smart factory examples. First, a GMP production workshop in Suzhou. Need, real-time tracking of drug barrels for asset management and production data. 5,000 square meters. Result, real-time drug barrel location, 0.3 meter accuracy in key areas, improving asset management efficiency. Second, an electronics factory in Shenzhen. Need, employee and important material management. 3,000 square meters. Result, 0.5 meter accuracy in key areas, effective employee management, and improved production efficiency. The last image shows a typical factory floor, highlighting the diverse environments where this tech is applied. This slide visually summarizes the breadth of their experience. It presents a grid of images representing various typical application cases, spanning factories, production lines, warehouses, railway vehicles, bridges, and other structures. The prominent text, 300 Ja Dancing Antli, translates to over 300 typical cases, emphasizing the extensive portfolio of successful deployments. This isn't just theoretical, it's a testament to the practical applicability and proven success of their positioning technologies across a wide range of industries and infrastructure types. Alright, let's pivot to their newer offering, UWB plus AOA. As we touched on earlier, this combines the strengths of ultra-wideband technology with angle of arrival. While BLE AOA, core location, is great for high-precision indoor positioning, UWB plus AOA core sensing takes it further by adding robust distance measurement and directional awareness. It's designed to meet the demands of applications requiring not just location, but also spatial context. Think of it as moving from knowing where something is to understanding its proximity and orientation in space. How does this UWB plus omnidirectional AOA work? It's based on ultra-wideband technology, which is known for its high-precision ranging capabilities. It uses miniaturized array antennas and sophisticated algorithms to determine both the distance to a target and its direction. The diagram shows the principle. A tag emits a signal, and the UWB plus AOA module receives it, calculating the distance and the angle of arrival theta. This combination allows for highly accurate localization between devices, whether it's robots following a path, luggage tracking, or automated gates. It's particularly well suited for high-precision applications where knowing the exact spatial relationship is key. A key feature highlighted here is the small size of the array antenna. This is crucial because it makes the technology suitable for integration into massive IoT intelligent devices. Think about embedding these modules into small robots, wearable trackers, or even everyday objects. If the antenna is bulky, it limits where you can put it. A compact design opens up possibilities for widespread adoption across various IoT devices, making the technology more versatile and easier to implement in diverse scenarios. This slide emphasizes the core advantage of their UWB plus AOA solution, the built-in high-precision positioning algorithm. It's designed to be deeply simplified and optimized, meaning it doesn't require external computing units. The diagram shows the architecture. A small array antenna feeds data into the module, which runs the distance and direction, finding algorithms. The results are then output directly via BLE or UART interfaces. This simplifies the system design significantly. No need for a separate, powerful processor to handle the complex calculations. The application examples, like the robot following a cart or tracking luggage, illustrate the ease of integration and deployment. Let's look at the product specs. Range and accuracy. Indoor up to 20 meters, outdoor open space over 100 meters, with sub-meter accuracy. That's pretty impressive for a single module. Time delay, less than 1 second, which is fast enough for real-time applications. Size and portability, tiny. 18 millimeters, weighing only 50 grams. Power consumption, very low, anchor average 2 milliamps, tag average 1 milliamp. Great for battery-powered devices. Anti-interference, features anti-multipath algorithms and optimization for body, wall shielding. Essential for reliable performance in complex environments. Built-in alarm threshold, allows setting safety, alert, and alarm distances directly in the module. Simple and easy to use, no external computing unit needed. UART output provides direct results. One-to-N support, can track multiple tags simultaneously. The image shows the compact module itself. These specs highlight a highly capable, efficient, and user-friendly device. What can you actually do with this UWB plus AOA tech? One prominent application is machine following, like a robot following a person or a vehicle. The IoT industry has many demands for this, often using visual or wireless solutions. Visual solutions are convenient initially, but they have limitations. Obstacles can block the view, creating blind spots. Lighting conditions can drastically affect performance. The UWB plus AOA solution offers a robust alternative. By having a module worn by the person and another installed on the robot can determine the direction of the person relative to itself, even through obstacles or poor lighting. This information is sent to the robot's controller to adjust its movement, achieving intelligent following. The image shows a robot potentially following a person, while the contact info is just standard marketing material. This slide shows the actual positioning effect of the product. While the image itself is just a contact banner, the context implies it's demonstrating the real-world accuracy and reliability of the UWB plus AOA module in action. The previous slide discussed the machine following application, so this likely represents the visual confirmation of the precise distance and direction measurements being made, leading to the desired behavior, like the robot accurately tracking its target. It's the proof in the pudding for the technical specifications. Another key application is car key positioning, a hot topic in automotive tech. Traditionally, UWB2F or TDOA methods are used. The diagram shows the old way. You need multiple anchors, 4 or more, installed around the car. The key communicates with all these anchors, and the system calculates its position based on the time of flight or time difference of arrival of the signals. It works, but it's complex and expensive. Now, look at the core UWB plus AOA idea. The diagram shows a single device installed in the vehicle. The key communicates with this single device. How does it work? The single device uses AOA to determine the direction of the key and 2F or TDOA internally to estimate the distance. The comparison table highlights the advantages. Fewer anchors, 1 instead of 4 plus, no need for complex time synchronization, similar coverage and accuracy, low latency, and significantly lower cost. This simplifies the system dramatically. Again, this slide shows the actual demonstration effect. The first image appears to be a setup for testing the car key positioning, perhaps with a tablet displaying the results. The second image shows the car key being located, likely using the single device approach mentioned in the previous slide. The contact information is standard. The key takeaway here is visualizing the practical benefit of the simplified UWB plus AOA solution for car key finding, making it more accessible and cost-effective for manufacturers. Finally, they mention a few more potential applications, hinting at the broad applicability. Amusement parks, camping, pets, malls, going abroad. The images suggest scenarios like tracking pets during camping trips, helping children navigate large malls, or even locating belongings while traveling internationally. It's a reminder that the underlying technology, precise positioning and direction finding, can be adapted to solve a wide variety of everyday problems and enhance user experiences in diverse settings. It's not just about factories and warehouses, it's about making life easier and safer in many contexts. Just a blank slide here, probably a transition or placeholder. And that wraps up our look at CoreAIoT's positioning technologies. Thanks for your attention.